In a previous video, we talked about comparing numbers with irrational exponents. In this video, we will continue this topic. Here comes the question. Prove that 2 to the power of square root of 12 is larger than 11. Similar to what we did before, since square root of 12 is a number between 3 and 4, we write it as 3 plus x. After a few steps of manipulation, we can get x is equal to 3 over x plus 6. Then, we define a number sequence xn, in which xn is equal to 3 over xn minus 1 plus 6. And we need to choose a number as x0. Of course, we can choose 0 as a starting point. However, we need to consider that square root of 12 is not that close to 3. So, if we choose 0 as a starting point, we might need to go through a few more steps to get a good approximate number. Instead, we can choose other values as a starting point. For example, 1 over 4, 1 over 3, 2 over 5, or 1 over 2, depending on how close this number to the integer. Since 12 is almost in the middle between 3 squared and 4 squared, we will give 1 over 2 a try. If x0 is set as 1 over 2, then from the definition of this number sequence, we can calculate x1 is equal to 6 over 13, and 3 plus x1 is equal to 45 over 13. This is the first rational approximate we find as square root of 12. But before we go further, we have to determine which one is larger, square root of 12 or 45 over 13. To do so, we just need to compare their square numbers, and we will find out. Square root of 12 is larger than 45 over 13, which means 2 to the power of square root of 12 is larger than 2 to the power of 45 over 13. This is exactly what we want, because from here, if we want to prove 2 to the power of square root of 12 larger than 11, we just need to prove 2 to the power of 45 over 13 is larger than 11. If the rational approximate that we find is proven to be larger than square root of 12, then unfortunately we might need to find another one. Okay, let's go back. This inequality is equivalent to 2 to the 45th power larger than 11 to the 30th power. And on the left side, we also want to get power of 13. So we write 45 as 4 times 13 minus 7. And we translate this inequality to 16 over 11 to the power of 13 larger than 2 to the power of 7. And similar to what we did before, we will use the binomial equation to estimate the left side value. We notice that 16 squared is very close to 2 times of 11 squared. So we write 13 as 1 plus 2 times 6, which is equal to 16 over 11 times 256 over 121 to the 6th power. And 256 can be written as 2 times 128. And 2 to the 6th power can be put in front. And the entire expression is written as 2 to the 6th power times 16 over 11 times 1 plus 7 over 121 to the 6th power. And this one, we need to use the binomial expansion to estimate its value. Before we go ahead, let's do a quick calculation of a over bn, which is less than 3. This is not a very big number, so we might need to calculate the first 3 terms of its binomial expansion to get a good approximation. It might not be needed, but to be safe, let's do so. So its first 3 terms is 1 times 6 choose 1 times 7 over 121 plus 6 choose 2 times 7 over 121 squared. And of course, there is a larger than symbol here. It can be further written as 2 to the power of 6 times 16 over 11 times 1 plus 6 times 7 over 121 plus 15 times 7 squared over 121 squared. So, if we want to prove 16 over 11 to the 13th power larger than 2 to the 7th power, we just need to prove the binomial expansion is larger than 2 to the 7th power. This inequality, both sides can be divided by 2 to the 6th power times 16 over 11. And then both sides can be subtracted by 1. Then divided by 3. Then times 8 times 121 squared. And it will be equivalent to the following expression. 121 times 112 plus 40 times 49 larger than 121 squared. Then both sides will be subtracted by 121 times 112. And the following inequality is equivalent to 1960 larger than 1089, which is of course true. So from here, we have proven that 16 over 11 to the 30th power is larger than 2 to the 7th power, and eventually we have proved that 2 to the power of square root of 12 is larger than 11. Job done. As a practice, you can try to prove that 2 to the power of square root of 11 is less than 10. I'll give my hint here. You can choose 1 over 4 as the x0. Thanks.